All right, hello everyone. Welcome to the Marshall W. Allworth Planetarium. My name is Jessica. I am the director of the planetarium and will be one of your show guides today. You've also met Brayden and Clay. We also have Rachel in the back. They are three of our students helping out tonight. And we got a super fun show for you, Beyond Bizarre, Strange Things in Space. So we're going to take a look at some of the weirder things that we can find in our universe. Now, if at any time you need to leave during the show, you're welcome to do so. You'll just exit through the same door you came in. Just be careful because it does get dark in here. And we like for our shows to, be more interactive and fun. So if you have any questions throughout the show, feel free to ask. Rachel can maybe watch for hands. Otherwise, you can just ask out loud. And if you're not comfortable asking during the show, that's not a problem. You can always find us afterwards and ask us questions as well. All right, I'm gonna head to the back and we'll get started. Okay. As I mentioned, our universe is full of some wonderful things, but also some strange things. And today we're going to look at a few examples of some of, I guess they're my personal favorites, strange things in the universe. And we're going to start off with a couple of things in our solar system, and then we'll move further and further out. So to get us started, we are going to head over to Saturn. Saturn, if you look at its North Pole, has this really strange feature. It has this hexagon-shaped storm. Now, this is a storm. This storm is circling at speeds of up to 200 miles per hour. And as you can see, inside of the hexagon, we've also got some little swirling vortices all around. Now, this is obviously strange to get a hexagon-shaped storm naturally in the cosmos. And just to blow your minds a little bit more, this is no small storm. So this is the Earth in comparison. One side of the storm is bigger than the diameter of the Earth. This is a giant, weird feature on Saturn. And for a while, we were uncertain of exactly how something like this could form. But some recent simulations and some recent lab experiments have been able to reproduce something similar to this. So I'm going to show a short video from one of these lab experiments where what they did was they took fluids and they had them going at different speeds as they circled the container. And as those different speeds interacted, they ended up naturally forming this kind of hexagon shape with other smaller whirling vortices within it. So this could very well be what's going on the North Pole of Saturn, where you have just different wind speeds, and they're interacting just the right way to create this weird hexagon shape. All right. Our next stop is going to be over to one of Jupiter's moons. We are going to go see the moon Io. Now, Io is one of the 4 largest moons of Jupiter. It's one of what's known as the Galilean moons, because the astronomer Galileo is the one who discovered these 4 moons. Io is another weird one. You see its color. This is pretty true color. You've got these oranges and yellows, and you've got these black spots all over. those black spots that you're seeing are actually volcanoes. Io has over 150 active volcanoes. And it's so active that we have been able to get multiple pictures of volcanic eruptions and lava flows across the surface. Now, this may not seem that weird because we have volcanoes here on Earth, not hundreds and hundreds of them like Io has, but volcanoes don't seem too unusual, right? Well, what gets unusual is when we look a little bit more at the moon itself. You see, Io here is a little bit smaller than our moon. And our moon, as you may or may not know, does not have any volcanoes. And that's because it's a pretty small object. Yes, in the past, it was a lot hotter inside, and that heat was enough to drive some lava flows across the surface. That's where our dark Maria come from. But the moon cooled off about 3.5 billion years ago and hasn't been active since, because small things cool off faster than big things. So something like the moon is going to cool down a lot faster than something like the Earth, which is much bigger. So given that Io is smaller than our moon, we expect that it should have cooled off. There should not be all of this heat inside to drive this volcanic activity. Well, it turns out our culprit for all of this, let me spin us around here and try and find it. Of course I can't find it now. Our culprit, there he is. Our culprit for all of this is Jupiter. Jupiter is a massive planet. It is about 10 times the size of the Earth and 300 times the mass of the Earth. So its gravity is a much stronger pull than the Earth's. As Io is orbiting around Jupiter, you have its gravity constantly tugging Io towards Jupiter. But Jupiter also has about 94 other moons, and they all pull Io back the other way. So Io is caught in this tug of war as it's getting pulled back and forth, back and forth. And as it's getting pulled, it's stretched and released and flexes and stretches. And this constant stretching and releasing is causing the interior of the moon to rub against each other. And just like you do on a chilly day, when you rub your hands together and they get warm, the same thing's happening inside of Io. And this tugging back and forth is creating an extraordinary amount of heat. And that heat has to escape somehow, and it does so through hundreds of active volcanoes. So it is a very strange moon, being so small yet so incredibly active. But this one we do understand it. We know that Jupiter there is the culprit for all of this. All right. We are going to head out of our solar system now and head to a different solar system. We are heading to a star known as 55 Cancri, and the planet around that star known as 55 Cancri E. It also has the name Janssen. And as you can see here, it is nicknamed the Diamond Planet. So let's talk about what's going on here. This planetary system is located about 41 light years from Earth. A light year is the distance that light travels in 1 year, and it's about 6 trillion miles. So we have this planetary system 41 light years away. And as we look at this planet, as we get data on it, we can figure out how big it is and how massive it is. So compared to the Earth, oops, come on, swing us around. My controller's not wanting to work for some reason. Come on. There we go. All right, so compared to the Earth, 55 Cancri E or Janssen is about twice the size, but it's about 8 times the mass. That tells us that this is a really dense planet. There has to be a lot of dense stuff inside of it, like carbon. As you can see here from the artist's rendition, the surface appears to be, or we think the surface would be pretty molten because this planet is really, really close to its star. It takes only 18 hours to complete one orbit around its star. So temperatures are getting up to something like 5,000 degrees on the surface. But the exciting thing is the interior. Because you have such a dense planet, we think that the carbon that makes up the planet is being squeezed under a tremendous amount of pressure, and that is creating diamonds. And estimates say that this planet could be made of about a third of it could be made up of diamonds. Now, it's still contested among astronomers exactly what this figure would be or if this is happening, but some of the data does suggest that we have a planet that's partially made of diamonds here. All right, one more planet I want to show you is the planet K2-18b. I know, not a great name. Not all things in space have cool names, unfortunately. But this planet, for a while, was thought to be Earth 2.0. So this system is a bit further away than Cancri. It's about 124 light years away. And it's in what we call the habitable zone for the star. So the habitable zone, also known as the Goldilocks zone, is the distance that you can be from a star and have temperatures on a planet be similar to the temperatures we have here on Earth. It would be temperatures just right for there to be liquid water, which means you could potentially have life develop, hence Goldilocks and, just right temperatures. So this planet, K2-18b, is in its star's habitable zone, in its Goldilocks zone. So temperatures could be similar to Earth. Now, the star itself, the planet itself is bigger than Earth. It's about twice the size, about 8 times the mass. So it's what we would consider a super Earth. And back in 2019, we actually did detect water in the atmosphere of this planet, which led a lot of excitement to thinking that we have found water in a planet that's a bit bigger than the Earth, that is in the star's Goldilocks zone. We could have found Earth 2.0 here. Now, I say could have because we no longer think that that's the case. As we have studied this planet more, we have found that it actually has a very thick atmosphere of hydrogen, more akin to the atmosphere of Jupiter, Saturn, Uranus, or Neptune. So we don't think that it's a super Earth, but it might be this weird new type of planet that we don't have in our solar system, which would be a water world, where you could have a thick hydrogen atmosphere and a world that's mostly covered in liquid. We don't have that here, but this could be one of these new types of planets that we have found. And of course, we just need more information. As we continue to study it, we'll get better ideas of its atmosphere and its composition, and hopefully be able to narrow down exactly what this planet is. All right. Moving away from planets, let's go visit a gas cloud. So a gas cloud in space is called a nebula. The one we are going to go visit is this one, the Red Rectangle Nebula. So this gas cloud is what we call a protoplanetary nebula. It's a gas cloud that is being created from a dying star as it spews out the gases that once used to be part of the star. What makes this so unusual is the shape. Let me show you what other protoplanetary and planetary nebulae look like. They're circular. That's because as stars, which are spherical, shed their gases, that gas tends to be pushed out in all directions, creating a more spherical or circular shaped gas cloud. You can start to see now why this one's so weird. We have this very angular, rectangular shape here, and we have not been able to figure out how this type of shape would have formed. There's got to be something weird going on within the star itself, or maybe some sort of debris field around the star that's helping to shape this rectangular shape of the nebula. But yeah, this is the Red Rectangle Nebula, and it's quite weird. All right, one more thing in our galaxy. We're going to head to the outskirts of our galaxy to visit the globular cluster known as Omega Centauri. So a globular cluster is essentially a huge collection of stars. It's usually tens to hundreds of thousands of stars. The stars are usually packed in really close together, like you're seeing here. And they typically, we find them on the outskirts of our galaxy in what we call the halo of our galaxy. Now, we know of lots of globular clusters. So finding a globular cluster itself isn't strange. What makes Omega Centauri weird is its size. So this that I just turned on in the center is the size of an average globular cluster. Omega Centauri here is several times larger and has millions of stars within it. So it is much, much, much bigger than any other globular cluster that we know of. And we'll take a closer look at it. With its approximately 10 million stars, we have a lot of stars packed in really close together. The core of this globular cluster is so crowded that we actually think you have conditions where stars actually collide with each other, which is not something that normally happens because generally space has a lot of space in it. Stars are really far apart. You don't get stars just running into each other. But it's so crowded and jam-packed in the center of this globular cluster that that's not the case. We do actually get stars that run into each other. Now, we think that this globular cluster did not start out as a part of our galaxy. We actually think that Omega Centauri here started out as a galaxy of its own, a dwarf galaxy. And as that galaxy merged with the Milky Way, our galaxy, the outer layers of the galaxy were stripped away. And what we're left with here is the core of this once dwarf galaxy. And that would explain why it's so much bigger than all of the other globular clusters we see, because it's not a typical one. It's the remnants of the core of a galaxy that merged with ours. All right, speaking of galaxies, I have one particularly weird galaxy to show you. So we're going to head out to what's known as Hoag's object. So before we can talk about Hoag's object, we have to talk about galaxies themselves. So galaxies come in three main types. We have elliptical galaxies, spiral galaxies, which is what our Milky Way is, and then irregular galaxies, which are basically the things that don't fall into either category. Now, usually, elliptical galaxies are galaxies that have recently interacted or merged with other galaxies, and that twists and distorts the shape. So we get this really random blobby looking galaxy. All right, so with that in mind and looking at what galaxies typically look like, this is Hoag's object. It's weird. We have what looks like an elliptical galaxy at its center, but then it's surrounded by a ring of gas and dust and young stars. So not quite a disk, but not just an elliptical galaxy either. And we are absolutely stumped in how a galaxy of this shape could form. We have no idea. Our first thought was maybe these were two separate objects, but as we have studied it and watched it, we have been able to tell that yes, this ring is orbiting around this central portion. The different colors you're seeing come from different ages of the stars. The center is more yellow-red because it has an older population of stars, while the ring is bluer, which means it's a younger, newer population of stars. So this must have been added after this part formed. But we don't know how it would have gotten this nice, neat ring shape. We don't know. And it's really weird, and I love it. And that's why I included it. Also, I just love talking about galaxies. What I did my grad school research on was galaxy evolution. So love talking about galaxies. All right. Our very last topic for tonight is going to take us back to our galaxy, to the very heart of the Milky Way, where lives an object known as Sagittarius A star. Sagittarius A star is a supermassive black hole that lives at the center of our galaxy. So a black hole is essentially an object that has so much mass concentrated into such a small volume that its gravity is inescapable. Not even light can escape from the gravitational pull of this object, hence why it's black, because there's no light coming from it. Now, black holes are not just cosmic vacuums. There is a limit. There's a point of no return. We call this the event horizon. Once you cross that line, that's when you're in trouble and the pull is too strong for you to escape. But as long as you are outside of the event horizon, you're fine, which is why we see things like this disk of gas surrounding the black hole. Now, black holes come in many different sizes. We have small, what we call stellar mass black holes that are the result of the death of massive stars. These stars are typically 20 to 25 times the size of our sun or bigger. When they explode, the core collapses in on itself and creates a black hole, like we just saw there. So these are small black holes, stellar mass. Then we have the thing that we see in our galaxy, this supermassive black hole. This thing contains about 4 million suns worth of material. And we currently do not know how a black hole of this size forms. For a while, we thought that maybe a bunch of smaller stellar mass black holes collected together, merged together, and this happened over and over and over again, and eventually you grew a massive black hole like this. But we're starting to find problems with that idea because we find these supermassive black holes not just in the center of our galaxy, but in the center of just about every galaxy. So this seems to be a natural part of galaxy formation. And when we look at really young galaxies, they already have a supermassive black hole at their center, much sooner than they should if this was a bunch of small black holes that were merging together to create a much, much bigger one. So we think there must be a different way that they form. How that is, we have no idea yet. One of the ways we're trying to figure that out is by studying these supermassive black holes even more. So you may have seen in recent years the first ever picture of the supermassive black hole at the center of our galaxy. And before that, we got a picture of the supermassive black hole at the center of the galaxy M87. So by studying these, we will hopefully learn more about them, but we also need to see if there is any medium-sized black holes. We have small ones, we have big ones. Do we have medium-sized? And that could help us figure out if we do go from small to big, or if the big ones form in a completely different way on their own. So this is a very active field of research. One of my past planetarium students actually did research on this. Eli did it. Yeah. So yeah, our last weird thing that we have in space. So that's just been some of them. I mean, obviously our universe is huge, filled with so many things and many, many other strange things. That was just a small selection of some of the ones that I particularly like. And hopefully you enjoyed those too. And that brings us to the end of our show. Are there any questions? No? All right. Well, thank you all for coming out to see us. It is too cloudy for us to do telescope viewing tonight, unfortunately, but we are doing them monthly. So check our website for next month. I think it's gonna be on like the 20th or 21st, something like that. Before you head out in front of the TV, we've got star charts and some other fun goodies. Feel free to take those with you. I will be back here if you have any questions. Otherwise, thank you again so much for coming to the show. I hope you enjoyed it. Have a safe trip home and a wonderful rest of your weekend.